Okay, this section continues. You want to backtrack to the previous video, which is 11, actually start at 10A. Okay, if you're going to talk about, you're going to do the airlift project, you want to go back to those videos, okay? So this is part 284C3m1b7c8e12c1. I'm talking about the last three numbers, so you go to 10A to get to the proper one. It's like 9 videos back, something like that, 9 or 10. Okay, so it's line 22f1fa19c3m1b7c8e12c1 Zingg Runge-Kutta time marching algorithm 5G Wow Seti. We talk about Professor Zing's work in the previous video. We study what he's working on and what his problems are. And guess what? I believe our wow alien signal is going to show you how to solve those problems, because a lot of the stuff that he's looking for came up, okay? So there's the alien radio signal there. And in this video, I'm going to be doing keyword research math equations for airlift formulas found in WOW line 22. Okay? So this one's got some formulas for you guys to try out for your airlift. This has to go to NASA if you want. You can send it to them. Somebody. Okay, so this is Professor D.W. Zingg, University of Toronto, Institute for Aerospace Studies. He's from Ontario, Canada. There's his contact information. He doesn't know I'm doing this video yet. I'm not sure if he'll find out about it or not. Okay, so www.utias.utoronto.ca. His personal site is goldfinger.utias.utoronto.ca. Okay, you can contact him there. December 17th, 2012 is working on this. Today's December 28th. The keywords from the data in the next video: Runge-Kutta time marching algorithm. Actually, it's in this video. Sorry, I usually change the words. I tried to do this quickly, so as you know, I'm trying to get this done before the end of the year, but it's doubtful because there's so much to do. So, quote from the blog: a parallel higher order Newton-Krylov-Schur solver for the three-dimensional Euler equations. Quote diagrams from blog: a fourth order Runge-Kutta time stepping as an operation graph posted on April 11th, 2012 by Jeffrey J. Early. So this is a brand new post. You can solve the initial value problem of y equals f to the y numerical by discretizing y into individual time steps. Starting with y at time n, Runge-Kutta time stepping algorithm computes y at time n plus 1 given f to y. Here's what it looks like in a graph. This is the fourth order Runge-Kutta algorithm. And you can see this on the website, okay? I'm just going to show it real quickly to you. So it's just a step-by-step of this algorithm that they've been working on. Okay, so, and this is his website, jeffreyyearly.com. Okay, I'll just go slow here so you can write it down if you have to. Okay, and let's backtrack. There you go. Can you see that? Okay, good. Okay, so quote from blog: Science. I am a physicist and specialize in not me, it's from him, okay? I'm a physicist and specialize this is Jeffrey talking. I'm a physicist and specialize in geophysical fluid dynamics. Currently, I do research at NWRA, studying inertial oscillations and eddies. And it's jeffreyyearly.com. That's an easier website to remember. Just go to this one if you want to look at his notes, okay? So, quasi-geostrophic equations, quote from Wiki. This is another keyword that we're looking at, okay? Well, geostrophic motion occurs when the horizontal components of the corolus and the pressure gradient forces are in approximate balance. Quasi-geostrophic motion refers to nearly geostrophic flows, where the advective derivative terms in the momentum equation are an order of magnitude smaller than the corolus and the pressure gradient forces. Okay, so there's a diagram to look at, and here's another one to look at. So quotes and diagrams from a blog. We investigate the effect of quasi-geostrophic potential vorticity PV perturbations have on the development of intense surface cyclones using the ED 1949 model without the upper rigid lid. The model consists of a basic state with constant vertical wind shear and thermal wind balance with a north-south temperature gradient. The flow is further constrained to be inviscid as well as having a constant static stability and Coriolis parameter F-plane. With the PV framework, there are two basic perturbation types that can be considered: boundary potential temperature PT anomalies and interior potential vorticity PV anomalies. Using these two perturbation types as building blocks, one can try to construct the normal mode structurally stable linear solutions. And that's from www.knmi.nl. Okay. So December 18, 2012, the keyword surface cyclogenesis continues in the next video. Okay, thanks for watching.